Hello, we're talking about aqueous solutions. Let's talk about the difference between dissolving and dissociating. Let's say sugar, for example, is a molecular compound that exhibits covalent bonding. And so the simplest sugar molecule is glucose, that can be drawn in this form, where at each of these corners of this hexagon there are carbon atoms. And the way that sugar dissolves in water is that you have these hydrogens, they're directly covalently bonded to oxygens. And of course, they can hydrogen bond. And so a water molecule can come along with this partial negative charge on the oxygen versus a partial positive charge on the hydrogen. And hydrogen bonding can take place between the oxygen and the hydrogen on the oxygen of the sugar molecule, or for that matter, the hydrogen on the water molecule can hydrogen bond with the oxygen, any of the oxygens are on the sugar molecule. And so that's how that crystalline structure of the solid sugar molecule becomes hydrated. You become hydrated when you're full of water. Molecules become hydrated when they're surrounded by water molecules. So this is how a molecular species becomes hydrated and becomes dissolved. That's different than something like sodium chloride that's ionic. And we've got this three-dimensional structure, the three-dimensional array of salt molecule, something that might look like this, where the greens would be the chlorides and the silver, much smaller silvers, would be the sodium ions. And so the water molecules can break down that three-dimensional structure. And once again, we've got our partial negative charge from the water attracting the complete positive charge of the sodium ion. So we can get some number of water molecules around the sodium, and likewise, the partial positives of the hydrogen on the water attract the negative charge on the chloride ions. And so that's how the sodium chloride becomes hydrated. And so both of these molecules, the covalent molecules and the ionic molecules, they both dissolve, but it's only the ionic molecules that actually undergo dissociation. And so ionic molecules, when they dissolve in water, become strong electrolytes, and that they can conduct electricity. These molecular species are non-electrolytes, and that they do not conduct electricity. Now there are some covalent molecules that are acids and bases, and they can partially ionize in water. And so the acids partially produce H plus, and the bases produce OH minus in water from these molecular species. And so they behave as weak electrolytes. And so there are a series of strong acids, HCl, HBr, HI, HNO3, H2SO4, and HClO4. Hydrochloric, hydrobromic, hydroiodic, nitric, sulfuric, and perchloric acids, and they dissociate 100%. So these would all be strong electrolytes. Anything else that acts as an acid in water will be a weak electrolyte. So that would be something like acetic acid, for example, the active ingredient that you find in vinegar, or citric acid that you find in fruit. So these dissociate less than 100%. In fact, it's probably down around 1% or less, something like that. And so it's important to know the difference between strong and weak and non-electrolytes. It's important to know the difference between dissolving and dissociating. Thanks for watching.